Yes, today we're going to talk about angle relationships, and our learning target is that I can define angle types and I can identify different angles. So first we're going to start out with angles. An angle is formed by two rays. Oops, RA. No, it won't let me write. There we go. There we go. Rays with a common endpoint. The endpoint is called the vertex. That's an R. All right, so here's a ray this way. Here's a ray that way. Remember, a ray starts at one point and goes on to infinity in one direction. The rays are called the sides of the angle. And we're going to name it generally using three letters. Okay, so the middle letter always represents the vertex. If there's not three letters, we would just use the one in the middle. We would just use the vertex. So for example, this we would label, or we would call angle A, B, C, or we would do angle C, B, A. But the middle letter is always our vertex. All right, and then if we're referring to the measure of the angle, like what degree it is, we're going to use a lowercase m. So we would say the measure of angle ABC is 60 degrees. And we would always use the degree sign. So there's types of angles. So you guys remember this from when you were little, right? You have an acute angle. It's so cute. It's less than 90 degrees. Oh, wow. Can you read that? I hope you can read that. It's less than 90 degrees. And then you have an obtuse angle, which is greater than 90. And then you have a right angle, which is exactly 90. And you know a right angle by this little box. It's always a right angle. And then you have a straight angle. And that is exactly 180 degrees. Okay? In this example, it wants the vertex. So the vertex, remember, is where the rays come together. So that's K. The sides are going to be KJ. And it's a ray, so you're going to have the two letters, and then it starts at K and goes through J. So the arrow has to go above the J because that's where it's going. And then the other side is KL. So it does matter how you write these. So it starts at K and goes across L. There's three ways to name this angle. We said we could use three letters. So we can either start with the J and K in the middle, and then the L. Or we could start with the L and then the K in the middle and the J, right? So we go J, K, L, or L, K, J. Or we could just use angle K. Just name the vertex. And then this is an obtuse angle because it's greater than 90. All right, for example 2, the vertex is S. The sides of the angle are S to R, and S to T. Three ways to name this angle are R, S, T, and T, S, R. Remember, the S has to be in the middle, or just angle S. And then this is going to be a right angle. And you can see that by the box. We never assume anything is a right angle. We have to see the box to know that it's right. All right, congruent angles are angles that have the same measurement. Okay, so since those are the same measurement, they are congruent angles. And we would write that as angle A is congruent, so it's an equal sign with a little squiggly on top, as angle B. All right, that's how we show two angles are congruent. And that just means that their measures or their degrees are the same. Okay, so the angle addition postulate basically says that if I have one big angle and I split it into two, right? So I stick another ray in the center. As long as this vertex is the same, then this angle on one side, if I take this angle and I add it to this angle, it equals the whole thing, right? So that means that angle ABD plus angle DBC is going to equal angle ABC, right? And when you write it like that, you should be able to take out this middle part, right? And then the B's should be the same. So angle ABC, right, is what you end up with. That's kind of how I write it. So it's not that picky. But basically, when you take one big angle or one angle of any kind and you put another ray in the center, then the one angle that's next to the other angle equals the big angle that you started with. That's all that means. All right, so if you know in this case that PQR is 141, so that means this whole big thing is 141, then that means that 82 plus X has to equal 141. So all I'm going to do in that case is subtract 82 from both sides. So X equals 141 minus 82, and that's going to give me 59 degrees. So 59 degrees is my answer. In this case, DEG is 112, and every time you have a picture, you should label it. Okay, GEF is 12x plus 8. Okay, find each measure. So what am I missing? So here I should recognize that this is a straight line. And we know that straight lines equal 180 degrees. So I should see that 112 plus 12x plus 8 equal 180. So I'm going to go ahead and combine my like terms here. So my like terms for this one are 112 and 8. So 112 plus 8 is 120. So 120 plus 12x equals 180. Then I'm going to subtract 120 from both sides. So that gives me 12x equals 60. This is minus 120. It's hard to see. And then I'm going to divide both sides by 12. So in this case, x equals, I think it's 5. Yeah, 5. All right. So if x equals 5, GEF is 12 times 5 plus 8. So we just said 12 times 5 is 60. 60 plus 8 is 68. So GEF is 68. DEF, this whole thing, we already said is 180. So there you go. Alrighty. Some angle relationships that you need to know. Vertical angles are two angles across from each other on intersecting lines. So anytime you have two lines that intersect like this, the angles across from each other are congruent. These are called vertical angles, here and here. Or you could say here and here. Okay, they go across from each other, and they are always congruent. That is very important. You're going to need to know that for all the proofs we're about to do. Adjacent angles are next to each other, and they always have a common side. So it doesn't matter how you draw them. Ooh, sorry, that's ugly. But they are always next to each other, and they always have a common side. So they could look like that. They could look like this. Okay, these two angles are adjacent. No matter what, they always share a side. A linear pair are adjacent and they form a straight line. So they are like this. They're kind of like the problem we just did. So these two angles together have to add up. Why won't it let me? There we go. It's a Y. They have to add up to 180 degrees. So supplementary means that they have to add up to 180 degrees. Okay? And they form a straight line. And they're adjacent. Because they share a side. Okay? Complementary angles are angles that add up to 90. They don't have to be adjacent. They usually are, but they don't have to be. So I could have this, right, where I have this one, right, and x plus y are 90, because 90 is complementary, right? So the big thing there is complementary. But I could also have, say, a 30-degree angle and a 60-degree angle, and say those two are complementary too, even though they don't share a side. All right, and then the same thing happens with supplementary. They don't have to be adjacent. To be supplementary, but they do have to add up to 180. Okay? So that's the big thing. We're going to use these vocabulary words a lot. All right, so let's look at some examples real quick and see what we can figure out. So here are vertical angles, right? So this is vertical. And that means they're congruent, so x is equal to 112. Here, these are complementary. See if I remember how to spell. Which means that x plus 68 has to add up to 90. So when I subtract 68 from both sides, I get x equals 90 minus 68, which is 22 degrees. Here, these are going to be supplementary. Right? We also call that a linear pair. Oh my goodness. My writing is getting worse. I'm sorry. Let's try that again. This is supplementary. And it's a linear pair. There we go. Which means that they add up to 180. So we have 124 plus x equals 180. So we're going to subtract 124 from both sides. And we're going to get x equals 56. All right. Now here we need to find x, y, and z. So I'm going to start with y because these two are vertical. So I'm going to say y is 43. And then I'm going to do, I'll probably just do z, or x and z are going to be the same because they're also a vertical pair. So I'm going to say x plus 43 has to equal 180. So I'm going to subtract 43 from both sides. And I'm going to get x equals, what's 180 minus 43? That is 137. So both of those, so x is 137 and z is also 137. Don't forget a little degree sign there. And y was 43. All right, and then this one is if measure of PQT. So PQT. So this is 3x plus 47, and SQR is 6x minus 25. Find the measure of SQR. So those are vertical angles, so they're going to be equal. So 3x plus 47 is going to equal 6x minus 25. So let's move our x's together first. So 3x, I'm going to move over here. I'm going to get 47 equals 3x minus 25. I'm going to add 25 to both sides. And this is going to give me 72 equals 3x. I'm going to divide by 3. And 72 divided by 3. That's 18. Nope, that's 24. Alright, so x is 24, but I got to find SQR. SQR is 6x minus 25. There we go. So 6 times 24 minus 25. And I'm just going to put that in my calculator. 6 times 24 minus 25. And I get 119. So that's the measure.